All right, so we're continuing 6.1. We did all of these examples in our 6.1 notes, and we graphed them, but we didn't plot points to graph. We kind of just did a rough sketch about what direction our graph is going to go, whether it was growing or we had exponential decay. But now we're actually going to plot points and give a more exact graph for each function. So looking at A up top, to give a more exact graph, we need to plot points. So for exponential functions, you always want to plug in 0, and then you want to plug in a number bigger than 0 and a number smaller than 0. The bigger the x that you plug in, the bigger your y is going to be. And it's going to get big really quick. Because if we plugged in 4 for x, remember, we could plug in whatever we wanted, but if we plugged in 4, that would be 2 to the 4th power, which is 2 times 2 times 2 times 2, so that would be 16. That'd be off our graph. So we kind of want to stick close to that x-axis when plugging in numbers for x. So we're plugging in numbers for x, getting our numbers for y, and then we'll have some points. So we want to plug in 0. What's a number smaller than 0 and a number bigger than 0 we could plug in? What's a number? Awesome. -1 and 1. So let's plug in -1 first. If we have 2 to the power of -1, what does that simplify to? 1 over 2. That negative exponent turns it into a fraction. So on our graph, we're going to go to the left 1 and up 1/2. So we'll have a point about there. Next, we're going to plug in 0. So we have 2 to the power of 0. What is 2 to the power of 0? 1. Anything that has the exponent of 0 is 1. So at 0, we're going to be at 1. So our y-intercept is always going to be 1 when you just have x in the exponent. So for all these graphs, we'll notice that our y-intercept is always 1. And then we can plug in 1, so we have 2 to the power of 1, which is 2. So we go the right 1, up 2. Once we have our 3 points, we just draw our graph. So here, do we have exponential growth or exponential decay? Growth. Not only can we see that we have growth by the shape of our graph, but also since this 2 is bigger than 1, we have growth. All right, let's look at B. Just looking at our base here, are we going to have exponential growth or exponential decay? Decay, because we have a fraction. Because we have a fraction that is less than 1. Now we're going to do the same thing we did before, plug in points for x, get values for y, and then plot our points. So what can we plug in for x? 0, what else? 1. -1. So for all of these problems, you can always plug in -1, 0, and 1. They're kind of just the easiest numbers to work with when dealing with your exponents. So we have 1/2 to the power of -1. What is that? 2 over 1. Just 2. So we're going to go to the left to -1 and up to 2. Next we plug in 0. So we have 1/2 to the power of 0, which is 1. Anything to the power of 0 is 1. So we stay at 0, go up 1. And then lastly, we plug in 1, so we have 1/2 to the power of 1, which is just 1/2. So we go to the right 1 and up 1/2. Once we have our 3 points, we can draw our graph. So our graph is decreasing, which shows that we have decay, so we know we graphed it right. Any questions on this one? All right, let's look at number 1. So we have y is equal to 4x, 4 to the power of x. So we're going to plug in values for x, get our values for y, and plot our points. What can we plug in for x? -1, 0, and 1. So we have 4 to the power of -1. What's 4 to the power of -1? 1 over 4. Perfect. So we go to the left to -1, up 1/4. Now we plug in 0. So we have 4 to the power of 0, which is 1. So we stay at 0, go up 1, and then we can plug in 1. So we have 4 to the power of 1, which is 4. So we go to the right 1, up 4, and then we connect our dots. Is this exponential growth or decay? Growth. Not only can we see that we're getting bigger, but we also see that we started with a number that is bigger than 1 for our base, so we have growth. Alright, let's do number 2. So y is equal to 2/3 x. What are we going to plug in for x? -1, 0, and 1. So 2/3 to the power of -1 would give us what? 3/2. Awesome. We just flip it. So we go to the left to -1 and up 3/2, which is 1.5. Next we can plug in 0. What's 2/3 to the power of 0? 1. So we stay at 0, go up 1. And then next we can plug in 1, so we have 2/3 to the power of 1, which is 2/3. So we go to the right 1, up 2/3. And then we connect our points. Do you have exponential growth or decay? Decay. All right, number 3. So we have y is equal to 0.25 x. What can we plug in for x? Bless you. -1, 0, and 1. So when we plug in -1, we have 0.25 to the power of -1. What is 0.25 as a fraction? 1/4. So this would be 1/4 to the power of -1, which would be 4. So we go to the left -1 and up 4. Now we plug in 0. So 0.25 to the power of 0 is what? 1. Anything to the power of 0 is 1. And then next we can plug in 1. So 0.25 to the power of 1 is 1/4, or 0.25. So we go to the right 1 and up 1/4. And then we connect our dots. For all of these graphs, notice how they never cross the x-axis. It's because the x-axis is our asymptote. So if I see on the test that you graph this and your line crosses the x-axis, it'll be wrong. For exponential functions, we never cross the x-axis. Do we have exponential growth or decay here? Decay. All right, last one. We have 1.5x. What can we plug in for x? negative 1, 0, and 1. So we have 1.5 to the power of negative 1. What is 1.5 as a fraction? 3 over 2. So if we had 3 over 2 to the power of negative 1, what would that give us? 2/3. So we go to the left negative 1 and up 2/3. What is 1.5 to the power of 0? 1. So we stay at 0, go up 1, and then what is 1.5 to the power of 1? 1.5. So we go the right one, up 1.5. And then we connect our dots. Do we have exponential growth or decay here? Growth. Not only do we see that we're increasing for our graph, but we also started with a number that is bigger than 1.